Figure 20.18, Standard Library Deck Class Template. And again, the name deck is sometimes pronounced deek as well. Now, in this example, we wanted to demonstrate just some of the capabilities of a deck, and it turns out that these capabilities are basically identical to the ones that are supported for class vector. The key difference between a vector and a deck is that vectors are optimized for always inserting items at the end, whereas decks are optimized for inserting items at either the beginning or the end. So in this example, we create a deck of doubles, in this case called values. We also created an OStream iterator that is capable of outputting doubles, and we're going to output them to cout separated by spaces. Here we demonstrate the push front and push back member functions of a deck. So we push 2.2 and 3.5 at the beginning of the deck and 1.1 at the end of the deck. So now we have 3.5, 2.2, and 1.1 in that order. Then we show you the contents of the deck, and just for demonstration purposes here, we're using array-like indexing to show you that indeed you can iterate, or index rather, through a deck object. So we start with the integer, the unsigned integer I, set to 0. As long as it's less than the size of the deck, we're going to increment I by 1, and in the body of the loop, we're going to be displaying the contents of value sub I followed by a space. So if we stop there and run this program, we can take a look at the first line of output and see that indeed we contain 3.5, 2.2, and 1.1. Now the next part of the program shows you popping an item from the front of the deck, and of course after you remove the item at the beginning of the deck, we expect the deck to contain one less element. And once again, here is the same copy algorithm, this time being used on a third different type of data structure, a deck, and we're simply saying go from the beginning of the deck to the end of the deck and copy the contents to the output iterator called output, which is of course going to place the items on the standard output stream with spaces in between. And if we stop there, we can see that after the pop, we have 2.2 and 1.1 left in the deck. Now at line 32, we also demonstrate that you can access elements inside of a deck using the subscript operator as an L value. And here we're saying replace what's currently at position number 1 with the value 5.4, and after doing so and then displaying the values, you can see that indeed 5.4 is now in the place where 1.1 used to be.